Well, g'day, Max there again. Welcome back to the shop. The old jacket on today. We've had a couple of days of rain. It's a bit cool outside. So what we plan to achieve this episode is we're going to go through the issue that we had with our taper angle on our gib strip, and we'll show you when the moment the penny dropped for me where we were, well, where things weren't going to plan. So we'll go through that and we'll have a test fit up of it, and then we'll carry out any scraping operations that may be required. So swing around to the mill and we'll have a look. Okay, so a quick basic recap. In the last video we could not work out why our angles that we machined the gib strip to were not matching a parallel measurement across here. So the end result of all our measurements, which were correct, what was playing in the back of my mind was this compound angle thing that sneaks in. So the penny didn't actually drop till just after I'd recorded the other video, and then it dawned on me straight away. I thought, you've missed it. And I did miss it. We had all the measurements there that we needed to do our compound angle calculations, i.e. this angle here relative to this angle, or this reference face here, and our slope angle there of 60 degrees. With that information, we should have used the compound angle formula to work out the correct angle to set our magnetic chuck to machine the gib strip to the correct angle, in a nutshell. Now, probably why the thought never solidly come to me in the first place was, if you just look at the gib strip, there's no compound angles involved when you're machining this face. You have your back reference face, and all you're doing is tilting the chuck, machining the top angle in relation to the back angle. It's all in the same plane. It's not until you go to fit the gib strip into position, after you've machined it, because of the wedge shape, when you rotate the part around, you create the compound angle, which is on the inside face here. It not only angles up, but it also rotates around. So there's your compound angle. So what we have to do now, what we'll do is we'll do a quick fit up. We might use a bit of blue, or maybe some feeler gauges, and we'll just check to see how our new machined angle matches both halves. In a future video, it's not going to be till next year, due to the complications involved with these compound angles, it's something that most of us, and I openly admit it, I hate the things. I hate dealing with them. We do have a machining fixture that we have to do, which is all compound angles. So we're going to have to go through the formula there, which is bloody complicated, to achieve our end result. Okay, the other thing I'll quickly point out is we machined about 1 thou off these two surfaces, and it's good to see our flaking for the oil retention is still there. I can still feel it with my fingers. So at least we got the original flaking in nice and deep, so we do not have to reflake it. The other thing is too, the reason why we didn't machine our gib and pick up the angle off the existing angle, there's two reasons. Because first one being, going back to the original cause of all our dilemmas, when the top of the compound was in place on the base, we were getting a lot of rocking. So the angle of the gib strip was out there, plus we did a lot of scraping on the thick end to try and correct that, and that's why we brought the whole lot back to this shop to do some measurements. The other thing that comes into play as well, we did a realignment of our dovetail angle here in relation to the edge of our compound, and that was so this edge can be used as a reliable reference surface should we need it for later on job setups or compound angle adjustments and things like that. That gives us a dead reliable reference, dead parallel to our axis of movement. So let's get these assembled up and we'll have a couple of measurements. So what I'd like to do first, we just slip the two halves together. Now we'll recheck the depth that our gib strip is going in. I know I'm going to have to put at least a 25 thou shim behind this gib strip. So that's the approach we will be taking over making a complete new gib strip, as shimming it, a gib strip, is a standard acceptable practice. There's no need to replace one unless it's completely knackered or broken, or you want to make a new one. So what we're going to do, if we push our compound as far as what it would normally go in its operation. Originally when we did this measurement, before we did anything, we were getting a 4mm discrepancy on how far the gib strip went in. After we had machined our dovetails and done our realignment, we were then getting a 3mm discrepancy. So now that we've machined the dovetail to the correct angle, which was explained how we did that in the previous video, let's poke it back in and check our discrepancy in depth. So we'll push it in. And we are reading 74.5mm. Knock it back out. We'll bring the compound back the other way to its limit of travel of what it would be. Poke our gib strip back in. And we're reading close enough to the same, 74.5mm. So that's a good thing. So we've gone from 4mm discrepancy down to 3mm, down to virtually nothing there. So we'll put our compound in the middle position and push the gib strip in with a ruler. And we're getting a little bit of rock down this end, but nothing up this end. So let's try that going all of the way back. Not feeling anything there. We'll try it all the way forward. And we're not feeling anything there. Okay, let's get an indicator set up and we'll actually do a physical measurement. So we slide the compound all the way back, push our gib strip home, and I'm pushing quite hard on this. We're getting 1.5 thou there. So we'll push it all of the way to the extent of its travel. Switch our indicator to the other end. I'm picking up about 3 thou there. And that's with me fairly pushing on it too. Bearing in mind our gib strip is only covering, there's the end of the compound down there, the lower housing. It's only contacting 1/3 of the length of the upper slide. Okay, so what we'll do next, we'll set up, let's get this gib strip marked up in blue. We'll pop it in. We might actually do it up properly with the screws and the handle. Now, I'm not going to use bearing blue for this first test. I'm going to use Sharpie marker, as I want to fit this gib in quite tight just to make sure it's fully seated. Bearing in mind too, there is a slight hump in this. It's minimal, but it's there, as you recalled when we measured in the previous video. So I just want to see what this is going to show up. Using bearing blue, we're probably likely to get too much smudging. We're not going to get a good reading at this stage, as the surface on here is straight off the milling cutter. It's not a scraped surface. So let's try the Sharpie marker method first, and we'll see what happens. Okay, we're all blued up. I'll just let that dry for a sec. I'll assemble this all up, and then we'll have a trial. So we have our gib strip in, assembled. It's lightly nipped up at this stage. We'll just see if we can get some wear marks on it. Okay, we'll pull it back out. Okay, we'll bring you down for a close-up of this one. It's looking not too bad. So we can see solid contact there, and we have a solid contact running from there through to here, as well as on the top from there. It is touching all the way at the top, but very faintly. So that's our heavier contact here. I'd say it's possibly due So remember we said we think this has this slight hump in the middle, which we found during our measuring process, and we put that down to the dip in the magnetic chuck causing that. So why don't we now, I think I'll give this a scrape from end to end. We'll scrape a crosshatch from end to end, and we'll come back and we'll just scrape possibly a section out the middle, and then we'll come back and re-blue it. So what I'll do is I'll turn it over. So if I put a mark at the back there and at the back here. So after our first cross hatch scrape, our second scrape will be in this area here, and then we'll put the gib back in. We'll take another print and see what's happening. So what I want to do as well before I do anything is, this is one of my good parallels, and this is flat across the top. This would be the most flattest surface that I have and trust. So we're seeing there the gib wants to pivot in the middle, indicating the high spot that we have here, backing up the markings that we have here. Okay, so now we can turn it over. We transfer our markings between those two areas. We just scrape that blue section there. So now we can see the areas that need a bit of attention. So we'll scrape the blue off there, and likewise in this area here. Okay, we'll have a re-blue. Okay, we're showing some good improvement there. This is one that's I'm finding a bit difficult to film. I can see it as plain as day, but the light blows out. So we're a bit thin right on this end bit, but we are getting some good contact. A vast improvement. So what we'll do is we'll repeat what we've just seen. We'll knock these high spots off, and I'll do that. I'll do the next one off camera and bring you back. Okay, with our next scrape, I've outlined with this texture the areas we're starting to get some really good contact. I'm struggling to pick it up on the camera. So I don't know how they do it. Maybe DSLR camera when the other guys film this sort of stuff. But basically, got good full contact down to here. It tapers off, we're in there, pitches up a bit, dips down, pitches up, and then so in all this lower area we're starting to get some really good bluings transferring through. So I think I might give this one more going over, then we'll assemble it up and give it another test fit. So I think we'll do one more scrape looking at this. It's coming along. We are making forward progress. I'm very happy with what we're seeing. So I'll give it one more before our test fit. I'm just doing short strokes on this one, just picking off the blue. Oh, that's looking better. Yes. Right, let's get another shot, a better shot of this. Okay, we're ready for a trial fit up again now. So I'm happy with the evenness of the pattern that we're getting with the contact. So let's have a trial fit up. So for this test we've blued up the dovetail and cleaned off the gib. I'm also going to fit my ruler in behind the gib to act as a shim. Okay, we'll try that. Okay, I'm actually quite happy with that. Let's bring you in for a better shot. I think I'll try a shot of this on my phone camera. So the question is now, do we take another scrape off this? And I'd say yes, let's do one more. We're just a bit light on this end here, but we have it all the way along the bottom and all the way in this area here, and just a bit light up the very end. So I think we'll go one more, then we'll slip it back in, and we'll also do the dial indicator test as well. Okay, so we're ready for a final test fit, hopefully final test fit anyway. Now, off camera, I went ahead and verified with the bearing blue that our dovetail that we freshly machined on this side matched up properly with the one on its mate over here, and it does. We then blued up the top here and slid the top half up and down just to see how we're travelling with contact over here. I'll swing you down and we'll have a look and see what's happening here. I draw So you can see basically there are our areas of contact. Now, to improve that, we would have to scrape the bottom. Am I going to scrape the bottom? No, not at all. The reason being is I would prefer to have a master reference plate, like a good granite plate, so I could get this properly. Well, I know I'd be scraping it flat. Running the way I've just checked it, we're running off our machining marks. So you could have a little bit of error in both, and if I start scraping this off, I could actually make it worse and end up chasing my tail. So I've opted to leave this well alone. We're getting good 100% contact on the inner dovetail there, and we're just going to let this wear in. But yeah, without a good master to get a good print on here, I feel I'd be chasing my tail, and yeah, like I said, it could make it worse. So we're going to leave that well alone. Now, we did go ahead and make our shim. Now, when we install our gib strip this time, because we have the shim in behind, we're going to have to use the cutout slot. And we'll just see where the gib strip ends up. So let's adjust the angle of the dangle on the old camera, and we'll do a reassembly and assessment. Now, the rear screw, I'm just feeling behind now. The gib strip isn't actually coming through far enough to contact the lowest position where the rear screw can go. This gib strip's 1/2 inch shorter than what it should be, because I cut 1/2 inch off way back when we first had the issues, as it was interfering with the way wipers, and I thought it was just a straightforward gib strip adjustment, and it wasn't. So anyway, the rear screw now becomes redundant. It's not an issue. There's plenty of machines. Bridgeport, for example, only use one screw, and the screw head sits in the slot as shown. We did previously mention, before we put the shim under this gib strip, the screw was sitting on the end of it. It's a modified screw someone's made, but now we've repositioned the thickness of it. We can now reuse the slot it is intended for. We'll just nip this up a little bit more. Okay. I'm actually quite happy with that. I'm going to run with this. Let's get a close up. So we're getting a fair bit of contact. Yeah, it's really good up this half here, which is good because this end here is the business end of everything, and we are a bit lighter, but we do have it. So I'm actually going to let this wear itself in. I'm not going to do any more scraping on this. I could chase my tail and get this better if I wanted to spend hours and hours and waste my time on it, but I'm not going to do that. I feel it doesn't need it, and it will wear in. So we'll let this go. We'll put it back in, and let's set up a couple of dial indicators and see if we're getting any unnecessary rock. And if we are, then we have no option then to go back and re-scrape this again. So for this test, as you can see, indicator on the top, and we're going to indicate off the bottom half. Let's bring it down a bit lower. So I don't have the gib tight at all. I mean, I can push this quite easy with one finger. Your normal adjustment would be a tad tighter than this. So we run it to the end as far as it would go. Now I'm going to try and rock the top, and I'm getting 1/4 thou. So we'll bring it back to the other end. Rock the back. And we're getting a hair over 1/4 thou. So that is really good. That's a really good result. Now let's swap the indicator over to the other side, and we'll check our reference surface. So on our reference surfaces here, we're getting a good solid reading of nothing here. So that's a really good result. Okay, so what's left on this thing? Well, we need to flake the underside dovetails purely for oil retention. So I'll get the strip back down, flipped over, and we'll have a look at that. And they are going to be a bit tight to get into. So on our dovetail, it's very tight to get into, and I had to grind the top, knock the top off my scraper so it would fit in. I'm just doing a straight cross hatch in here. It's actually a bit difficult to get in there to see, but so that will give us a little bit of oil retention there. So there's no need to do the other side as the gib strip backs under it, and there's no need to do the gib strip as it's we've already scraped it, and there's enough oil pocketage in our gib strip. So if anyone's wondering about this tool here that I use, this scraper here, this is made by a chap over in England. He has his own YouTube channel. His name's Matthew, and his channel is Look Creations. So he makes these and sells them. He has an absolutely brilliant series on refurbishing an old worn out Holbrook lathe, where he scrapes the entire lathe and does a fantastic job of it. Absolutely brilliant. So normally people use carbide inserts for their scrapers. The reason I don't is because I don't have any. It's something I still have yet to purchase, as the scraping caper is new to me. So in the interim, I've been using these, cutting them off and re-grinding them. So what these are veins out of a hydraulic pump, and they're hard as hard can be, glass hard. But still, cast iron sort of hammers them a bit, and so yeah, they've got me through this job. So possibly next year we could look at upgrading our scraping equipment, i.e. carbide insert. We might have to get a slow speed grinder, or make one, and a bit more a 60-degree prism type thing for dovetails, and possibly a granite block as well. So anyway, that's another story. Yeah, well, I think we better close this one off here, otherwise we'll be getting too long. So at the end of the day, all that we've got left, as we said, is those couple of oil holes to drill and cleaning and reassembly. So I'll bring you along for the reassembly, and in that video, because the reassembly will be a pretty quick process, we will have a look at the cross slide and keep our fingers crossed that it's just a simple refit. Yeah, we'll see. So anyway, yeah, don't forget, check out Matthew's channel at Look Creations if you want to see a really fantastic rebuild done on an old worn out lathe, all hand scraped in his back shed. So brilliant channel, and yeah, that's where he does these scrapers as well. So now hopefully I'll get another video out before the end of the year. I can't promise. All I wanted to do was get through the worst of this compound slide. Now we've sorted out all of the issues. We should be hopefully plain sailing for a while again. So I have a lot of commitments over at the new shop with regards to power and this and that, and so that's going to take up most of my time from now through till Christmas. If I get the opportunity to knock out another video, I will, and if I don't, I don't. It's just the way it is. So if I don't, have a good Christmas, cheers, and we'll see you in the new year.